What I'm going to talk about in the next, hopefully, 15 minutes is what are we trying to do in this space, a solution, and what we're doing in terms of some of the projects. So I'm Janani. I'm with Technip Energies. It's a large technology and engineering company which has been around for 60 plus years and transforming itself every few years or decades. So last 3 years we've created Technip Energies with the ambition to really grow into a technology company for the sustainable future. So Professor Rajneesh already set up a little bit of that outlook. So I'll focus really on carbon capture. We talked about how much emissions needs to be abated by 2050. That's about 75 gigatons per annum. Of that, we expect CO2 capture to contribute about 6 gigatons per annum. So it's a huge number, and keep that in mind as we look at the next slide. So today, installed capacity of CO2 capture is about 56 MTPA. 6 gigatons per annum, 56. That's where we are today. But at the same time, we have a lot of projects in the pipeline, and the expected is about 610 MTPA of CO2 capture possible based on about 700 plus projects that are there today. And the expectation is to grow to about 885 MTPA in about a decade, right? So that's the kind of installed capacity of CO2 capture we are talking about in the decade, but growing from 56. So there is a huge growth potential, but doesn't come without challenges, right? So the first and foremost challenge is storage and transportation. That's a huge challenge in terms of accessible storage, transportation, economical storage and transportation. Second is government policies and funding. That is critical to make this affordable. And third is the technology itself needs to be made affordable and investable. But there is hope, I think. I'm an optimist. So today we see the levelized cost of CO2 much higher than what is affordable just based on carbon price. So that's where a significant amount of government funding, incentivization, etc. is needed. So in the rest of my presentation, we'll start focusing more and more on the global projects. It's not so much on India because we don't have that much today in terms of incentivization to make this happen. And then as we go future, we expect that the cost reduction also happens, the carbon pricing increases, and then the gap between the levelized cost of CO2 and carbon price decreases. And hopefully in the future, we can look at a more self-sustaining market with the green premiums, the CO2 sale for utilization, all of these picking up. Our role in Technip Energies is more focused on this cost reduction aspect. That's what's in our control, and that's what we are working on. So let me talk a little bit. So it's the whole suite of CCUS offerings and technologies. I am not going to talk about all of this. I will never make it in time. So pre-combustion is something that is existing for a long time because that's what the oil and gas industry has been doing for a long time. What we're doing now is more the treatment and the, the capturing and then the sequestration of it. Post-combustion is the most challenging aspect because CO2 concentration in post-combustion is very low and it's at low pressure. So that's where it gets quite challenging, and that's what I will focus on. And then you have the rest of the challenges on transportation, storage, etc. So I'm just going to talk about capture today. What we are working on is we have an exclusive alliance with Shell on the CANSOLVE technology. So Shell CANSOLVE technology is an amine-based capture technology. So one of the most advanced capture technologies today, proven at scale. And that's where we have an exclusive alliance with Shell as Technip. So you can imagine the CANSOLVE technology is sort of like the engine of the car, right? So you have the engine of the car, but then you need everything else around it to work to make a good, affordable, comfortable, luxurious car, whatever suits your need and requirements. So that's where we come in. So we are the technology partner and integrator, and working with Shell Technology, and that exclusive alliance helps us work together in terms of sharing confidential data and being able to really improve that technology. And it's actually quite a unique alliance. No other integrator has such an alliance with a technology partner in this space. And our focus, like if you remember, I talked about the three sort of challenges, and to make that happen, one of the things is making the technology affordable. That's where our focus is, and focusing on the carbon capture technology, which is about 60% of the cost. So we are focusing on both the CAPEX and the OPEX improvements around the carbon capture technology, mainly focused on standardization and productization and optimizing the supply chain. So we are trying to basically say, yes, you need continuous improvements on the technology, but you don't need to create bespoke solutions for each project, because that is not going to give you the cost reduction that you're looking for. So we're not trying to make first of its kind each time. It needs to be standardized, it needs to be productized, so we can really bring down that cost, and we can start making this a bit more of a reality than it's today. So when I talked about standardization, this is what we have in terms of offering. It's standardized, but at the same time, there is quite a range possible, right? So you can go all the way from a pilot scale, which is 1.5 kilotons per annum. It's modularized. It can actually fit into 2 into 40 feet containers and just transport it around. And then you have different sizes all the way to C200, which is the 200 kilotons per annum. And then we have what's called a C++, which is basically anything bigger, which then becomes more bespoke design. So the small and the medium ones are perfectly containerized and modularized. The bespoke one is also modularized, but it's more, the sizing varies. And then we also have a marine solution that we are looking at. So today, the largest size that we're looking at is about 2 MTPA of CO2 capture. So the amine absorber is actually quite constraining in terms of the size. So when you already go to about 2 MTPA, we're talking about a 60-meter high column. So if you try to make it any bigger, then it just becomes too big to manage. This is where I'll try and spend quite some time. So these are some of the key projects that's ongoing today. And this is also choosing some things across different sectors. There's many more. We have about 100 plus CCUS projects that we've been awarded over 2023, 2024, with greater than 30 MTPA of CO2 captured. But just the 4 projects here to talk about the different sectors for which CO2 capture is key, right? The first one is on the waste to energy sector. So Viridor in the UK is a large waste to energy player, so converting non-recyclable waste to energy. And I think Professor Rajneesh mentioned, right? So when you convert something, what you're essentially doing is you're releasing CO2 at the end. You're burning it to release CO2. And that CO2 needs to be captured. So 1 ton of waste to energy conversion leads to about 1 ton of CO2 that needs to be captured. So we have the feed for this, so front-end engineering design for this is completed, and we've rolled over to EPC that we're expecting to happen soon, and that's about 900 KTPA of CO2 capture. In the UK has been very active in CCS, so they've assigned about, I think, promised 22 billion, close to 22 billion pounds of funding over the next 25 years to support the CCS projects. And they are actively involved in selecting the clusters, selecting the projects, selecting where, what happens. And this goes into the first tier of these, first track of these projects into what's called the high net cluster. So there's a cluster in the east T-side that has been decided, and then there's a cluster in the northwest high net. So these 2 clusters have been decided, and these projects feed into that. So the first one feeds into that northwest cluster. Then this is cement project. So ignore the net zero cement. So the cement projects is at 1.6 MTPA capture. The idea is to capture all of the CO2 that's being emitted in this cement plant. It's in Canada. It's again backed by the Canadian government. We are in the, so we've already set up a pilot there, which has been operational for over 6 months in Canada, and now we're completed the feed for it and waiting for decision and starting to prepare for what's called as final investment decision. And that's a full-scale CCS. It's newly built, right? So it's a fully newly built cement, and we'll have a full-scale CCS in there. And then the third one there is in the US, so in the Calpine US, and that's a 2 MTPA for a gas power, so delivering more than 740 megawatts of clean power. This also has DOE funding, so DOE is, I think, funding more than $200 million for this project. So we are in the feed phase for this. So the UK ones, I just want to mention one thing that I forgot, is the UK ones are all, the first tracks is for 2030. So all of these are expected to be operational before 2030, because this is part of the net zero plan for UK in 2030. And the last one, again the UK one for gas power, this is for the T side. So this is the one in the north and the east side. So that is, we've already won the EPC award for this towards FID. And this is touted to be the largest full-scale CO2 capture for gas and power. And we're doing this in partnership with GE Vernova and Balfour Beatty. They're the local construction company. And we also try to do that. We also try and use local construction companies in multiple places. So the gas power in US, that's also being done with Bechtel as the construction, while we do the engineering and project management. And as of last week, we were also awarded one more feed for UK for a combined cycle gas turbine with Uniper, and again feeding into the HyNet cluster. So just a bit of an overview of what's happening in the world today. It's a long journey to get to where we need to get to by 2050. There's a lot that needs to be solved. But some of the governments, especially in the UK and the US, there's quite a lot of push and incentivization, which is helping these large-scale projects to be, realized. That's my last slide. I think I talked quite a lot through all of this. This is how we're all setting ourselves up to be future-ready. It's not an easy problem. It's something that we have to work with together. I think India has ambitions, but India also has struggles in terms of storage and transportation and the technology affordability. But we're also putting together a new version of the CCUS roadmap. In fact, Technip is part of the development of that too, in terms of how do we set our policies, etc. I will stop at that.